Hi, I'm Kirsten Sockwell, and I'd like to introduce you to nuclear waste. It all begins when we mine uranium primarily from the ground. America depends primarily on their stores, with 90% coming from the Midwest. However, that's only about 4% of the world production of nuclear, or uranium, excuse me. Of that natural uranium we pull out of the ground, less than 1% can be used for nuclear power. We can enrich it and take it up to about 3%, but that leaves 97% as waste. Now, after the nuclear cycle, we have the 97% of uranium as well as any side products made during the cycle. Those are all listed as waste, and we have to do something with it. So you can either reprocess it or store it. The reprocessing method is a direct descendant of the original method from the 1940s. It requires a lot of labor, takes a long time, and it's not very efficient. It's primarily used by France and Japan. Only about 33% of the world production of waste is even reprocessed during the year. So in America, we only store it. Now, if you look at this map right here, you can see not far from us is actually a storage site with about 40 million gallons of waste. That's about as much oil that was spilled in the Exxon Valdez oil spill in 1989. That's the second largest oil spill in the nation's history. So that's right down the street from us. The other important thing is in Hanford, Washington, the largest site in the nation, it's already leaking radioactivity into the groundwater. So we want to stop that. So my research is focusing on a key difference between most metals and uranium. So if you see right here, most metals are a spherical shape, while uranium naturally binds to two oxygens, making it a cylindrical shape. I'm designing molecules that will bind the entire cylinder rather than binding that sphere, which will prevent any alternative binding of spherical metals. This is an example of one of my molecules. If we can do this, we can pull the uranium out of the waste, which will decrease the amount of waste, as well as decreasing the environmental impact of nuclear waste. And this is also important because studies have found that uranium, the natural uranium, will actually run out within 80 years. So if we can use that 97% that was thrown down underground, then that will increase the amount of time that we can use nuclear energy without having to look for other sources. Thank you.